Alright, so looking at our do now, it says we're about to switch your books from your order during passing period, but you forgot the order of the combination on your lock. You know that the numbers are 3, 16, and 21 in some order. It says, what is the percent of locker combinations that start with a 3? So we're looking for the percent of combinations that start with 3. So it's the percent of the total number of locker combinations that start with 3. So Q is equal to percent times whole. Whole would be our total number of locker combinations. In this case, that is 6. And how many of them start with 3? So 1, 2. 2 is equal to percent of 6. We get 2 over 6, which simplifies to 1 over 3, which would give us 0.3 repeating, which would be 33.3%, or approximately 33%. Alright, let's flip on over and write down our aim for today. Alright, today's aim, Kipsters will be able to solve percent in solve 4% in counting problems. And actually, in a lot of ways, this is kind of a preview of some of the work that we're also going to be doing next unit when we get into statistics and probability. It says all of the 3-letter password combinations that can be formed using the letters A and B are as follows. So it gives us all of the combinations. It says what percent of passwords contain at least 2 B's. So Q is equal to percent times whole. What's the whole? So we're thinking about the whole is our number of possible passwords. So if we count them out here, they are all listed. There are 1, 2, 3, 4, 5, 6, 7, 8. So our whole is 8. And we're looking at our quantity and how many of them contain at least 2 B's. So that's 1, 2, 3, 4. So 4 is equal to percent of 8. Divided by 8, we have 4 out of 8, which is 1/2 or 50%. What percent of passwords contain no A's? Alright, so same whole. Count it out. How many of them contain no A's? Well, circled here in red is the only one that contains no A's. 1 is equal to percent times whole is 8. We get 1/8, which simplifies out to 0.125 or 12.5%. And it tells me how many 4-letter passwords can be formed using the letters A and B. So here we have to start thinking about writing out all of the different passwords that can be using the 4 letters A and B. So actually, there's, we got to be really organized about this. For me, I think about I can take every one of these passwords and I can either add an A to it or a B to it at the end. And that's pretty much going to be everything. So basically, I'm just going to take all of the passwords that I have before. I'm going to list them all out. So A. So that's my original one, and I can either add an A to it or a B to it. Alright, then I look at my next one. A, B. And A, B. I can either add an A to it or I can add a B to it. and I want to go through continuing to do this, go ahead and see if you can't finish making the list on your own and determine out how many different combinations there are. Alright, so coming through, I've made the entire list, and I count out that there are a total of 16 different passwords. So we're looking for here 16 different passwords. Again, I just started with each and every one of the passwords from above, and I just added either an A or a B onto the end of it, and that gave me my total number of passwords. So what percent of the passwords contain no A's? So again, we're thinking about this Q is equal to % times whole, where our whole is the total number of combinations, and our quantity is the number of passwords that meet that criteria. So go ahead and, on your own, answer questions A through F. Alright, just a quick check-in so far. Looking at these three problems, we should have that there are two combinations that have exactly one A. That is the exactly one A is ABBB and BBBA. So those are 2 out of 16. 2 A's, there are 6 of them, so we get 6 is equal to % times whole divided by 16 gives me 0.375. Make sure that you've gotten these 3 up here done as well before you check them using the video again. Alright, so looking at these 3, I count that there are 2 combinations that is exactly 3 A's. There's only one combination that has all 4 A's, and there are 6 that have 2 A's and 2 B's, the same number of A's and B's. Alright, in a set of 3-letter passwords, 40% of the passwords contain the letter B and 2 of another number. Which of the sets below meets the criteria? Alright, so looking at this, go ahead and see if you can figure out which of these that would be true for. So you'll probably want to set up a Q is equal % times whole for each of them to figure out which of them actually meets the criteria, and then go ahead and give me an explanation. So go ahead and do that on your own. Alright, so looking through at this, I'm looking at set 1. I can see that set 1 has a total of 15 combinations. Set 2 has a total of 10 combinations. And I count the combinations. Which set below meets the criteria? Alright, the criteria is that they contain the letter B and 2 of another letter. Alright, so that's B, and then it's going to be double something else. So BCC counts, BAA counts, ABAA or ABA counts. There's probably another one in here. AAB counts, CBC counts, and I know that CCB should also count. Any other? Okay, 3 B's, 2 B's, 1 B but no double letter, no B's, 1 B but no double letter. Alright, and it goes for, this looks like we've got the right set, so 6 out of 15. But divide both sides by 15. It gives me 6 over 15, which I know also simplifies to 2 out of 5. which is equal to 0.4 or 40%. Looking at the other set, set of 4, we're looking for combinations that have one B and double letter. So there's one B and a double letter, one B and a double letter, one B and a double letter, and one B and a double letter. Divide both by 10. And it also gives me 0.4, so it looks like kind of a trick question here. Our answer is that both of them meet the criteria of having exactly 40% of the passwords. So explain how we arrived at our answer. So something along the lines of a combination. We found the total number of possibilities in each set. That was our whole, and that our quantity was the number that met that criteria. And so we counted that out, and it was similar. So there's in proportion here, they have the same set of quantities. All right, let's flip on over and look at the other side. All right, Shane read the following problem. It says, how many letter arrangements can be formed from the word triangle that have 2 vowels and 2 consonants? Order does not matter. She answered that there are 30 arrangements. 20% of the letter arrangements began with the vowel, with a vowel actually had an English definition. How many of the arrangements that began with a vowel have a English definition? All right, so we're looking at this. Q is equal to percent times whole. We told the whole number is 30 arrangements, and that 20% or 0.2 meet the criteria. And so our quantity that would be representative of that would be 0.2 times 30, which is exactly 6. So there would be 6 of those words that have definitions. Alright, it says using 3 different keys on a piano, a songwriter makes the beginning of his melody with 3 notes C, E, and G. From the list above, what percent of the melodies with all 3 notes are different? Alright, so you're looking for combinations with all 3 notes different. Go ahead and answer questions A and questions B for this problem on your own, and then check in. Alright, so looking at this, Q is equal to percent times whole. And we're looking at the whole number I can count is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21. Alright, so looking at this list, there are 21 possible combinations, and I want to know what quantity of them have all 3 notes different. So let's see, this one, this one, this one, this one, double G, double G, double E, double G, double E, double C, this one, triple G, this one, triple, triple, or double, double, triple, double, and double. So I count 1, 2, 3, 4, 5, 6 of the 21. Divided by 21, divided by 21. This simplifies to 2 out of 7, which is approximately 0.286, or approximately 28.6%. From the list above, what is the percentage of melodies that have 3 of the same notes? So that's going to be E, 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 C, 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 and G, G, G. these ones that I've circled in red. So that's going to be 3 out of the 21. So my quantity is 3 is equal to percent times the whole, which was there are 21. Divided by 21. That's the simplification. Oops, 21 is same thing as 1 out of 7, which I'm going to have to round, is approximately 0.143. Which is approximately 14.3%. And finally, last problem, it says look at the 36 points on the coordinate plane. With the whole number coordinates between 1 and 6 inclusive, so we've got it all drawn out over here on the left. It says how many points have a coordinate of where x and y coordinates sum to 7. So for example, the point 43, the x and y coordinate would add up to 7. So I'm just going to kind of jump through this, starting here at over 4 up 3. So 4, 3 does. So I'm thinking about different combinations here that would work, like 2, 5, 6, 1, and we can actually see that it kind of follows a pattern coming down here, and that there are 6 of them. How many points have an x-coordinate and y-coordinate with a sum of 6? So I'm thinking like 4, 2, 3, 3. So 4, 4. Let's see, 4. Sorry, not 4, 4. 3, 3. Sorry, 3, 3. 4, 2, 5, 1, 2, 4. Okay, so again, kind of follows a pattern there. There are 5 of them. Sum of 5, that would be like 2, 3, 3, 2. So 2, 3, 3, 2, 4, 1. Have an x-coordinate, sum of 4. So that's going to be like 2, 2, 3, 1, and 1, 3. Sum of 3. 3, 1, or 1, 2, and 1, 3. Or 1, 2, and 2, 1. And finally, sum of 2, well, that's just going to be 1, 1. And kind of going back the other direction, sum of 8, that's going to be like 4, 4, 5, 3, so on. So that's going to be these over here. There are 5 of those. 9, that's going to be our combinations of 5, 4, 6, 3, 3, 6. 4 of those. As we can kind of follow the pattern here, we would expect this to be 3, 1, 2, 3, 2, and then 1. Alright, so that's going to help us answer the question, what percent of the points have a sum of 7? So we said that there were a total of 6 different combinations. Q is equal to percent times whole, where there are 6 combinations of 36. Is going to be the same thing as 1/6, which is going to be 0.166 repeating, or 16.6 repeating percent. Write a numerical expression that could be used to determine the percent of 36 points that have a combination of sum of 7. So that means it's actually not asking us to solve, where Q is equal to percent times whole. Our numerical expression is just what we wrote over here was the equation. It says what percent of the 36 points have a sum of 5 or less. So this one we have to be careful with. Sum of 5 or less. So that's going to be all of them that have a sum of 5. So there's some 4 that have a sum of 5, but or less. That's also going to include sums of 4, sums of 3, and sums of 2. So you need to add that all together, and that gives you a total of 10 possible combinations. 10 is equal to percent times total of 36 combinations. Do the math there, 27.7 repeating. And what percent of 36 points have a sum of 4 or 10? So we're going to be counting up the number that have 4 or 10. So the number that have 4, we have listed here is 3 or 10. There are 3 that have that combination. So that's going to be 6 is equal to a percent of our 36 total. And that's going to give me 0.166 repeating, or 16.6 repeating percent. All right, go ahead and flip on over and complete your alone time.